we will be launching one new process generation every year for the next several years. With 22 nanometer, it only gets better. 22 nanometer can reduce active power by 2x with density increments of about 2x. Now, I'm sure some of you saw the news earlier this month about the revolutionary new transistor architecture Intel has invented for 22 nanometers. As part of the announcement, we made a video in which we shrunk our senior fellow, Mark Bohr, down to 100 nanometers to show how different these transistors are. But of course, our researchers are used to doing things in the safety of a lab. I thought it would be far more interesting to do it live. So I gave Craig and the demo team the ultimate challenge. How did he do it?
Sean, you know the demo team would never let you down. So what I have right behind me is we're going to introduce live on Computex stage this year the Sean Shrinkinator. We're still working on the name a little bit, but it's all teched out and it's ready to go. So all you need to do is step inside, safety first, Sean, make sure you grab those. Step inside, and then I'm going to use the awesome power of the second generation core machine here. We're going to rearrange the molecular structure and shrink it down to about 100 nanometers. How do you feel about that?
It sounds simple enough.
Of course it is, a piece of cake. So we've rigged a tiny little camera down here, and so once we get you down small enough, we'll still be able to communicate between you and I and back to the audience. So hop right in.
You've tested this, right?
Test is always a relative term, Sean. Let's just, we're going to do this live. All right, Sean. Here we go. Shrinking down.
Wow! Whew. What a ride! Thanks, Craig. Can you see me and hear me okay?
You're looking good from up here, boss.
Great. Well, I'm now approximately 100 nanometers tall. Way smaller than this human hair, which is not mine, of course. It's also the perfect size to give you an up-close look at a single transistor, like this one. This is a planar or 2D transistor, the kind that has been at the forefront of transistor design for the last 40 years. And this is Intel's new 3D transistor. We call this a tri-gate transistor. It operates at a lower voltage with lower leakage for dramatically improved performance and energy efficiency. Now, you can't do a whole lot with just one transistor, but when you configure 1 billion or more of them in a single chip like this, things really start to get interesting. Craig, bring me up to the next level.
Okay, next stop on the shrink train. Here we go.
Great. So here is our 22 nanometer Ivy Bridge chip, populated with over 1 billion transistors. Now, add some smart software to a chip like this, and you can enable all kinds of useful functions with the benefits of greater performance and lower power with higher degrees of integration. This is the transistor architecture that will enable another billion people to join the internet revolution, whether by notebook or smartphone or whatever comes next. Now, that's a pretty big deal for such a tiny piece of technology. Craig, beam me up.
Okay, coming on back to full size.
Hey, Craig, what's going on up there?
Some technical difficulties, no problem. It's always harder to bring him back.
Okay.
Oh, okay.
Well, excellent.
I was a little worried about that one, Sean.
Yeah.
Had us going there for a bit.
Thank you.
Thank you.
So that gave you a glimpse of 22 nanometer. The byproduct of pushing harder in this device space will also help us bring new innovation to the PC space. The PC segment continues to grow rapidly. Today, we're shipping about 1 million PCs a day. That will nearly double in 5 years. So how is this possible? Right now, about 1 billion people own a PC. The affordability gap keeps another 3.5 billion out of the market. Closing the affordability gap is one of the smartest strategies the industry can pursue. This chart looks at how many weeks of income it takes to buy a PC. As you can see, there is a sweet spot where the curve accelerates. That's at roughly 3 to 4 weeks of income. Because of that, the chart is weighted towards developed markets. Watch what happens as we shift this chart forward to 2015. Emerging markets grow to almost half of the TAM. The number of people who can afford a PC goes up dramatically. Clearly, the PC market has very strong potential, but we can't rest. The PC must continue to evolve. Consumers are demanding new experiences, and the PC has to be able to meet those demands. Simply put, the PC must undergo a major change again. Think back to the shift from a desktop-centric compute model to the introduction of Centrino and mobility in 2003. That kind of change. So how do we do it? We change it from the inside out. How it looks, how it feels, how the user experiences it. Sandy Bridge is the first step in this transformation. Sandy Bridge UFV upgrades the notebook with a new class of thin, light, beautiful designs. You will see some of them here today. But we can't stop there. One of the things we learned from tablets is the vital importance of system response time. Users simply do not want to wait for a device to boot up. Can you blame them? Just imagine if people operated the way some PCs do today.
上可以再上网的，准备上学，不然要迟到了。
好，
亲爱的，我走了，别忘了帮你的耶稣打猎演唱会的票哦，晚上见。
爸，拜拜。
哦，拜拜，早点回来哦。各位同志，我这边有2张难得一球的苏打绿演唱会 VIP 门票，不知道有没有人要啊？不要。
这么晚了，不要一直上网，该睡觉了。
好，宝宝晚安。妈，你知道吗？有时候我真希望爸能开始开机。
对呀，宝贝，也许是该升级的时候了。
So, responsiveness matters. And to give you an example of how we are addressing this issue, I'd like to ask Art to show you 2 features that will be available in the market really soon.
Hi, Sean. So I think we can help that guy out. We've got a couple technology demos here to show how Intel continues to work on making the PC even more responsive than it already is. So the first one I have here is the Intel Smart Connect technology. And what that does is it enables your system and your connected applications to always be updated, even if it might be asleep. So to explain how that works, I've got several connected applications on the screen and have the camera come in close. And I've alerted all my friends to help us find some Soda Green concert tickets. I know you're a fan. So we're going to go ahead and see if anybody's come out first and what's on the screen. So the first connected application I have here is my email, and I've got one email here, and there's nothing about Soda Green. So the next one is Twitter, and last week is from New York Times. So again, nothing from Soda Green. And of course, I've got my Facebook there, and the last post is from my friend Bill. So nothing from Soda Green quite yet. I'm going to pretend I have to run off to the meeting or the airport. I'm going to close the lid. That's going to put the system into standby, or S3 for the techies out there. And then what the Smart Connect technology is going to do is periodically wake up that system, just briefly check and see if there's any updates or emails, and then put it back to sleep. And so when I come back here and open it up, I'll have everything. We'll have to wait because I know I'm going to have to jump on this TikTok right now. So we're going to let that sleep for a second. I'm going to go to the second technology we have. This is the Intel Rapid Start technology. And the best way to show that is I have it already booted. I'm going to play my favorite scene from that clip that we were just watching. I'm going to hit the power button, but the power button is actually tied to putting this into hibernate mode. So the Intel Rapid Start technology is actually taking the system state and the application state and writing it to a dedicated flash drive on the system, and it just takes a couple seconds to put it into hibernate mode. But once it's in hibernate mode, it uses no power. Right? I didn't say little power, and some people might not believe that it's using no power, so I'm actually going to do a bit of risk taking here. Pull the battery out, look, no wires. I'm going to put it back in. And if I was in any other mode, power saving mode, I'd have to reboot the system from the beginning. So Rapid Start technology takes about 5 seconds to come out of hibernate. And boom, went right back up. It actually started playing the video right where my favorite scene is. So
One more note about hibernate mode is that it's something that exists on our PCs today, but it's something that it takes a little bit longer than most users want to resume. So they typically use the S3 standby state, but there's a big difference in battery life. With the S3 resume, it's about 2 to 5 days of battery.
Right.
And then with hibernate, you get up to 30 days of battery.
Wow.
So it's a big difference between the two. So let's come back to our Smart Connect, and as soon as I open up, you can see, boom, I've got 3 emails waiting me, telling me I better get on some Soda Green tickets. I've got 5 new tweets that are telling me I've got my Soda Green tickets right here. And then over on Facebook, I have somebody emailing and said I better jump on these tickets. So even though it was asleep, it was actually able to keep everything updated. So both of these technologies are coming to a Sandy Bridge system soon. In fact, I have one that's fresh out of the this is a beautiful design from Compound, Ultra Thin and Light. And it's actually got both of these technologies built in already. So very soon this will hit the market.
Great. Excellent. Thank you. The beauty of these features is we don't have to wait. They can be deployed on PCs now with Windows 7. We'll start rolling out these capabilities for the holidays. We're not waiting. They will ship in higher volume over the next several quarters as more and more designs enter the market. The new notebook computing experience will soon be defined by secure, ultra-thin, ultra-responsive designs without compromised performance. I mentioned earlier that we can now start this transition with Windows 7. So who better to give us their perspective than our friends at Microsoft? Please welcome Mike Angelo. Welcome.
Thank you very much for having me.
Great. Intel and Microsoft have been doing things for so long. Can you talk a little bit about that?
Sure. Well, Intel and Microsoft have been working together for more than 20 years to deliver innovation across many technology areas. With Windows 7 and second-generation core processors from Intel, we've enabled industry-leading performance, increases in battery life, and thin and light PCs with excellent overall system efficiency.
Right.
We've started working together at the very beginning of Windows 7 in the research phase, and we saw some opportunities to make Windows 7 and Intel technology work better together to deliver a better overall PC experience. One of the focuses was multitasking. We know that most people want to do multiple things on their PC at the same time, and second-generation Intel core processors, together with Windows 7's new preemptive multitasking architecture, delivers a very responsive experience for the most demanding multitasking tasks. We've also collaborated to optimize Windows 7 to take full advantage of the new and improved hyper-threading and timer coalescing so you get better efficiency at scale.
That's great. One of the key innovation areas we're excited about is ultra-thin and ultra-responsive notebooks. What's your take on that?
Well, we've worked together to make this generation of ultra-thin notebooks better than ever. We didn't even need to use your super shrinker to make them thin. For example, take this Lenovo X1. This is a really great form factor. This is a Core i5 second generation Sandy Bridge processor in a rugged, thin and light enclosure. You can see you were talking about responsiveness. This comes right back from sleep in just a couple of seconds.
Yeah.
But let me show you an example of the performance. Here's Internet Explorer 9. And this was running one of the HTML5 tests from the IE Test Drive site.
Yeah.
And what's going on is that right now we're using CPU only to render all 90 of these letters in parallel. If I let it run to completion, it would take almost an hour. But if I go in and turn on hardware acceleration, I can offload the HTML5 to the GPU side the Sandy Bridge processor, and that same,
That's the Sandy Bridge processor, right?
and by doing hardware acceleration, when I restart IE, the same demo that would have taken a full hour to complete will run completely in just 8 seconds.
Wow.
So this is an example of hardware acceleration that we worked on together.
Right. The ultra-responsive category is really an exciting one.
Yeah, I think it's great. And I think today, Intel delivers the widest range of systems from the smallest netbooks and notebooks to the biggest servers that we've ever supported. And working together, we've improved performance and efficiency across that entire range. Intel and Microsoft are continuing to work together as we speak on next generation solutions that will further push that envelope as our customers continue to expect more.
That's excellent. Thank you.
Thank you.
So, integrating these features, as I showed earlier on Sandy Bridge, is the first step in recreating a new computer category. It's more than just a ULB processor in a thin design. It's a no-compromise version of what the notebook can be. We call it the Ultrabook, and I believe it could represent 40% of the consumer notebooks sold in the next 18 months. We need your help, Taiwan. Now, let's talk about step 2. The next evolution is just around the corner, and we could call it Ivy Bridge. It's step 2 in reinventing the PC and the PC experience. Ivy Bridge is built on our industry-leading 22nm process. It will bring power efficiency to the notebook PC and unrivaled security for consumers. Identity theft protection, better encryption, and malware detection. But that's just the baseline requirement for the next generation of our notebooks. We can't stop there. We need to find new ways to generate excitement around the PC and enlist the support of our ecosystem. One thing we are already doing is radically changing the I/O bottleneck. You may have heard about Thunderbolt. I believe it can open up new ways as we reduce the I/O bottleneck. Craig, why don't you give us a chance, show everyone what I'm talking about?
Absolutely. So Sean, I have some Thunderbolt devices here, and when we're talking about, everyone knows that Intel makes extremely fast PCs. But getting data in and out of that platform is kind of the next generational problem that we want to go ahead and solve. And our answer to that is Thunderbolt. So, let's go ahead and talk about a great example of moving all this large amount of data. When you plug in your flip, Sean, to your laptop, how long does it take you to get some of your HD flips off of there? Quite a while, yeah? So, when we're talking about is particularly all the consumer level handycams, well, what we did here is put together a professional scenario to show you just how much Thunderbolt is going to help you even when dealing with these incredibly massive files. So actually what here I have set up is it's a full professional studio built on Thunderbolt devices. Like this Promise, we're using SSD Intel RAID here, as well as the star of our show. This is the Black Magic Design box. This is actually input-output device that using Thunderbolt, and you can see here I have multiple connections all the way from your consumer level cameras all the way up to HD SDI for the ultimate in the pros. And then obviously our Thunderbolt connections to both the RAID and this MacBook Pro, the very first laptop to integrate Thunderbolt technology. And let's go ahead and tie it all together for our actual input device. This Hollywood quality camera that we have here from Sony is basically capable of taking the highest definition quality video, and at the same time we're going to real time input it into our box here for playback and capture. So why don't we go ahead and just move us around. Sean, if you wouldn't mind indulging me maybe in a little bit of a clip. Pretend like you're having a good time, like we just got back from the bar. All right, something like that. And this high quality video that we're coming in, Blackmagic actually supports up to 2K resolutions, even stereo 2K resolutions for 3D video capture. So I guarantee James Cameron gives us a call right after this keynote. However, let me just play back some of this quick content. And as you can see here, literally the about 15 seconds that we captured is about 2.5 gigabytes of data just in what we captured in that very short segment right there. So as for the first time ever, not only are you looking at solving this problem previously on all these huge workstations and specialty cards and racks of equipment, I've now made the world's first fully portable production level movie studio, all built on Thunderbolt devices. So Sean, the future is here. You and me can fulfill our dreams of quitting our Intel jobs and becoming professional movie studio directors. Are you ready?
Yeah.
All right. Thanks, Sean.
As you can see on the slide behind me, we are doing our part to ensure the ecosystem is ready. Thunderbolt will change the way we use PCs. It will provide opportunities to bring new devices, storage and media to the market. And data transfer speeds will be lightning fast. There are many other new capabilities on Ivy Bridge you'll be hearing about over the coming months. You don't want to miss our Intel Developer Forum in the fall. Taking together Sandy Bridge and Ivy Bridge are the first two steps in reinventing the PC and creating the Ultrabook category. We will do our part to build and price our ULV roadmaps aggressively. We need to make thin, light, ultra-responsive and secure notebooks part of the mainstream. And when I say mainstream, I'm talking about hitting volume price points. Enough of me talking about this. I'd like to invite a good friend of mine to join me on the stage to show off a killer new Ultrabook and get his perspective on the change I just outlined. Welcome, Johnny. Welcome, Johnny. It's great to see you.
Thanks, Sean. It's great to be here on stage with you once again.
Yeah.
Yes. To be honest, we are all very, very much touched by your spirit, your perseverance. You are delivering the great, great keynote speech. May I invite all of our audience to give another big hand to Sean. Well, let's go back to your main thing.
Yeah.
I think, I think at ASUS we are very much aligned, with the vision of the PC you just outlined. And thank you for making us ASUS, the first PC vendor to incorporate the latest Intel technology. In fact, we have taken many steps to ensure that ASUS can meet this kind of application. Transforming the PC into an ultra-thin, ultra-responsive device will change the way people interact for PC. Consumers are demanding an uncompromised computing experience in a ultralight, highly portable design that responds to your needs instantly. So Sean, I would like to show you a design.
Great.
We're about to launch.
Wow.
That I believe will encapsulate, much of what you just described. Okay, this is truly ultra thin. It's only from 3mm to 16mm. It's really ultra responsive. I think with your FFS instant on feature that can hibernate to zero power state and then resume in around 5 to 6 seconds. We also support the ASUS proprietary instant on feature that can hibernate up to like 7 days. So we can instant on, resume in 2 seconds. So you can choose both. And this is also ultra powerful, equipped with your second generation Huron River processor. And of course, this is ultra beautiful. So you may notice that it's a aluminum unibody design, and also watch the metallic spun finish here.
Right.
I think you will love it.
Yep, yep.
So this is for you.
Thank you. It's a gorgeous looking machine, Johnny.
Thank you.
Thank you.
Chris?
Okay, so I've told you about the first 2 steps. Now it's time for the third. The third step is perhaps the most radical. Beginning in 2013 with a product we call Haswell, we'll change the mainstream notebook design point by the overall power by 50%. Ultra thin, ultra responses with IA performance will be the uncompromised norm. Imagine the form factors and battery life we can achieve with this innovation. My guess is your engineers will be very busy dreaming up incredible new designs and usages. As we innovate across these categories I've mentioned so far, it's very important that everything works together. Craig, what have you got?
Sean, you've been talking for a bit. Why don't we come on over, have a little bit of a sit down. Maybe a Taiwan beer or two. I got some popcorn on over here. Let's just go ahead and have a little bit of a relax, shall we? Oh, I'm sorry, Taiwan beer. I got a Guinness for you, my man. There you go, right there. And Sean has been talking about all these great devices working together, playing together, and creating all of these great new usage models. Well, wouldn't it be cool? As you can see, I have this little device in my hand. It looks like a little iPod. And wouldn't it be cool with just a quick flick of my finger here, I could go ahead and do something like that. So you see, as I've actually run this up to the display of the television here, it's actually what we're doing is securely and locally connecting to my Core, second generation Core laptop over here via wireless and paired up with basically any device I want, and then I can go ahead and it opens up a whole bunch of other usage models for me, like connecting it up to a TV, either via HDMI or in this case WiDi. So some really cool stuff, but Sean, that's got the iPod there, but as you can see here, why don't you go ahead and flip through some of those pictures. Now that's not an Apple device or an Intel device. We're looking at, that's an Android tablet. So as you can go ahead and throw up, we have some great content, as I can see there, coming in from, it looks like a snowy Japan day. And then, well, over here I got some pictures of the Disneyland vacation. So let me go ahead and throw these up as well. or maybe even play a little bit of a video trailer if we want to go ahead and throw something up like that. So as you can see, securely pairing literally any device I want, iPad, Android, tablet, anything together to give great experiences like this, as well as share all your media back and forth. Because truly, when we're talking about the Intel continuum, all these devices working together, Sean, it's not just the Intel devices. We want every device to work together, because that's going to give you the greatest experiences that we've basically seen on all these devices, Sean. Pretty cool stuff.
Excellent.
Thank
Okay. As devices and PCs capture the public imagination, the cloud and the data center have to keep up. The load that these devices are putting on the cloud should not be underestimated. Every tablet, every smartphone, every PC connects to the cloud. As the volume grows, so will the need for the bigger, faster cloud. In the next 5 years, there is significant growth expected in the number of connected users, resulting in an explosion of data. Managing and making use of this growth in data is exciting. It's also challenging. For consumers, it means that everything you want your technology to do just works. But that just works experience is not easy to replicate. There will be some infrastructure challenges. Efficiency, security, resource capability need to be addressed. The three pillars of our cloud vision will help advance the cause. Point number one, the cloud needs to be federated. Data must be shared securely across public and private clouds. We need to create and promote standards that embrace this approach while having the right security in place. Point number two, it must be automated. Managing the cloud can't be a burden on IT. IT people should focus on innovation, not data center management. Point number three, the cloud must be client aware. More and more devices will connect to the cloud. The cloud needs to be aware of what those devices are capable of. Let me now show you a real demonstration. And Chuck.
Hey Sean, how's it going?
Yeah.
So you were talking about the cloud and how it can be very hard to make that transparent to all its users. And it is, it's very difficult to implement correctly. But to make it intelligent, to make it secure, and to make it efficient is even harder. So I'd like to share with you a vision of how we can use Intel tools and computing solutions to make that happen. Now on the screen behind me here, we're going to have two screens pop up. We've got one, a map of the United States. We've got data centers on both the east and west coast. And the other window is just a snapshot of those data centers and their current status. Now what we'd like to happen is our data centers to migrate workloads efficiently and intelligently to the most efficient data center. Now part of that efficiency can be measured on the amount of power and the type of power that it's going to use to power those servers. So we'd like to move those workloads to spots where that power is a bit cheaper. So you can see on our map of the US, we've had sunrise hit the East Coast, and our Atlanta data center, which is powered by solar power, now has the cheapest power in the US. So our Portland, Oregon data center transferred all those workloads to our Atlanta data center. Now it's important to note that it transferred those workloads using AES and TXT. That guaranteed that those workloads arrive safe and secure and were executed as cheaply as possible. Now, we don't want our data centers just to do that at certain times of the day. We want our data centers to constantly monitor those workloads and move those to the trusted pool that's going to effectively and efficiently execute those workloads. Now, throughout the day, that's going to happen, and then as night falls, right here you can see nights coming to the East Coast, those solar panels in Atlanta, those are going to come offline. So power is going to get more expensive on the East Coast. So our data center in Atlanta is going to migrate all those workloads back to Portland, Oregon, because now that is the most efficient way to execute those workloads. This is just an example of how we can use Intel tools and processing technology to make this cloud vision come to life.
That's excellent. Thank you.
Thanks, Sean.
And to illustrate why all of this is so important, look at this graph behind me. There's a lot of money in the cloud. Cloud services ranging from storage to entertainment delivery are exploding. And the beauty of all this for the cloud, it makes the cloud bigger. For every 600 smartphones deployed, one additional server is needed. That adds up quickly. So, as I said at the beginning, Taiwan and Intel's partnership is the foundation of the computing industry. We have delivered the power of computing to over 1 billion people. Now is the time to reach the next billion. Taiwan and Intel know how to do this. We've traveled this road before. Thank you and have a great Computex.